make sure you're being kind because your mom and dad can listen to this too. All right. What's that? For sure, it's all on YouTube. It's all public. They can get it. All right, ladies and gentlemen. So that realization, I hope, does not affect whether or not you answer. In fact, I mean, they can't see you. They're just kind of listening, and it's all good. I just want to make sure that the whole reason for this is that if you happen to be gone for whatever reason, right, then you have access to it. And I'll show you. I put it all up on Canvas so you can just access it any day, anytime. It's all there. So if you miss Capture Question 3.7 because you're just like, funny zone today, you can go back and watch it, listen to it, know the answer. Here we go. So what is the difference between a refracting telescope and a reflecting telescope? Do you want to get us started? No. Come on, my friend. Yeah.
Okay, I don't think this is right.
That's okay. No apologies necessary.
I said refracting bends light and reflecting.
Ooh, I love it. So refracting bends light. That's what you said, right?
Yeah.
That is exactly right.
Whoa.
Nice work. Refracting bends light. You guys remember when you were looking through the lenses when we had our little telescopes or our little optical benches set up? So literally what happens, you can take physics with me and we'll go through it and we'll actually draw the pictures and you'll see exactly what happens. But literally what was happening is that the light from, this was the card that had all the letters on it, right? It was coming through and then it got bent inside that lens, okay? And it got bent inside that lens and then those things get bent and then you can see them better. That's exactly what's happening. And again, we can talk about in physics exactly how that works. I heard somebody say when we were doing that they're like, I already have lenses on my eyes, right? Because you have glasses. I don't know if there's somebody in this class or the other class, but they're like, I already got that. And then but the funny thing is, I almost turned around and said, yeah, we all do. Because not only do you have glasses, so Desiree, you've got lenses right in front of your eyes, but Liz, you have lenses too. And I don't even know if you wear contacts. I'm assuming you don't. If you don't wear contacts, you still have lenses because your eye does the exact same thing. The front of your eye, there is a lens that literally collects the light and bends it to get it to what they call the ocular nerve, which is how you see things. Okay? So there's a lens in your eye. And so if you have lenses, either contact or glasses lenses, they're bending the light again to help focus the image better. Just like when we had those two lenses and you could change the distance. You remember when and so it got fuzzy first at some point and then it got more crisp at another point? It was literally bending the light to give you a focused image. Yeah?
Does that mean we have refracting eyes?
Indeed.
Oh.
Yes, your eyes do refract the light. I don't know that I guess I've never heard it said that you have refracting eyes because I don't know what other kind of eyes you would have. But yes. Yes. Your eyes do refract the light. They do bend the light. What does the word reflecting mean? What does it mean to reflect? Sends it right back. It bounces, right? Yeah. If you look at a mirror, you look at your reflection. Are you with me there? You've seen that. You've heard that word before. It's reflecting. That's exactly what it's doing. So instead of the light going through for reflecting, it bounces. The light bounces like off of a mirror. Okay? And then from that can be focused. Bends light to focus it. Focus or magnify. Okay? So you read about those. We experienced the idea of a refracting telescope. You may have seen mirrors that do funny things to light. They don't just bounce back. If you look at a mirror when you're brushing your teeth in the morning, the image that you see is essentially the same as you, right? It looks like you and it doesn't look distorted and funny, okay? But you may have seen mirrors that make you distorted, like look funny, right? So like I think like funhouse mirrors, like if you ever do a carnival, right? The ones that I love that make, my less than 5 foot body look really tall, like, oh, I'm so big, right? Or the ones that make, my husband who's a lot taller look really, really short, you know what I'm saying? So I like to line it up where I'm standing in the really tall one and he's standing in the really short one. I'm like, ha, now I'm really big, right? So those mirrors, the way that it works, stop. Friends, stop.
I don't think
They bend the light, or they bounce the light off of the mirror, and they cause it to be focused in a different way. So they make me magnified, right? So depending on the shape of the mirror, just like depending on the shape of the lens. So this is lenses, this is mirrors. I'm going to write that down too because that's important. Okay, depending on the shape of the lens or the mirror, okay, you can get different images. And we like to use that to look at the stars. We like to use that to look at a lot of things, but we're talking about the stars because we're in Earth and space science. Who's known for inventing or using each type? Who's got that? Galileo. Galileo's known for using which one? It's a 50-50 shot, isn't it? Yeah. This is from the video that we watched, the 400 years of the telescope. That's where we started this. Okay. Which one was it? Refracting. Galileo is known for the refracting telescope. Okay. Do you remember that they were talking about there was some guy talking about like the spectacles, right? So people started using spectacles. Then all they're like, oh, we'll put them in a tube. And then we can start looking, and the telescopes were originally just kind of a funny toy. Like, look at this fun thing. Little kids would like look, like they could look out into the ocean. They could like see a ship that was far away, right? And then Galileo was the first person, instead of going like this, to go, whoop, and then look at the stars. Now, was he literally the first person to do that? Probably not, because probably people were like, whatever. But he was the first person to understand like the power of that, right? Whoa, I can look at the moon and I can see some stuff. Big deal. Okay. Who invented the reflecting telescope? I heard somebody say, but I don't know what it said. Isaac Newton, yes. I'm not a fan of the guy, but it is what it is. Yep. Isaac Newton, he was the first person to come up with the idea, or to publish the idea. Again, maybe not the first person ever, but the first person that is, or the person that is credited with coming up with the idea of the reflecting telescope. So the reflecting telescope uses a lens to focus the light and then uses a mirror to bounce the light so that we can see it too. Got it? This would probably be good information to know tomorrow. Just saying. All right. So done with that. Check. Next thing that I want you to do, we are going to do the first of the gravitation investigation. We're going to do it together, though. So I want you don't have to get your computers out yet. Just sit tight. Just sit tight for a second, then I'll let you fill it in a little bit. Okay? So I had to run down to Ms. McGrain. She's one of the other earth science teachers, to go get a toy from her. Okay? So I want you to take a look at this cute little toy. And it was funny because we were talking about this one day at lunch. And Mrs. Ellickson, who's another one of the science teachers, she has a baby who's maybe, I don't know, like 2 years old or something. She said, I have one of those in my house. And I'm like, yeah. But it's good science that happens to also be in a baby toy. So that's exciting. Okay. So I want you to just kind of imagine if I put an object right up here at the top and I let go of it, what do you think that object, like that ball, is going to do? It's going to go zoop, zoop, zoop. And it's super fun. It's fun for little kids to look at, and it's fun for big kids to look at too. Okay? It's pretty exciting. So this is what happens when we go zoop, 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 zoop. So I'll just let you see how exciting it is. Are you ready? So here it goes. We're going to go like this, and I'm just going to go. Is everybody watching? Okay, 3, 2, 1, go.
Wow.
Right? It's exciting. Isn't that good? Okay, and it goes in a circle, and circles are fun. And circles are fun for lots of reasons, but the reason that we care about circles is what, David? Why are we talking about circles today?
Telescopes.
Wrong answer. Good guess. Good guess. We're talking about what did we look at through the telescope that we care about with circles? We've been talking about this a little bit. Ellipses and orbits of planets and stars and moons. Yeah, so we're talking about the circle stuff. So we spent some time this unit, just kind of give a quick little review of the unit. We spent some time this unit talking about Was the sun at the center or the earth at the center? That was what versus what?
Heliocentric versus geocentric.
Awesome. And we've decided that it was what?
Heliocentric.
Heliocentric. So we know that it's heliocentric. We know that because we've gotten some data, right? We got some data. Who took the data? Do you remember? Brahe. And then who interpreted that data so that we got good evidence that it was heliocentric? Kepler. Kepler was our guy, right? He knows, again, maybe not the best character, but he figured it out. So we know that we're heliocentric. So we got that much, okay? And that's all well and good, but now today we're trying to figure out why. Why do we live in this heliocentric solar system, okay? And the short answer is this. Ready? 1, 2, 3, go. Whoa, what happened there? Gravity, right? Gravity that causes this ball to fall, and it also causes this to happen, okay? It also causes the orbit to happen. So the first question that I'm going to ask to you, and you can write this down. You're going to write it down in your thing in just a minute, but I just want you to write it down on your paper somewhere. On your capture question is fine, or whatever piece of paper you have out in front of you is fine. Pull that out. I want you to make a prediction for me, something that we're going to come back to at the end of the period today. So here we go. You notice that I put my hand right here. I'm going to do it again so you can watch it one more time. It's going to go down, down, down. Whoa. Okay, it goes like that. If I move my hand, and I put it down on the table so it doesn't fall, that would be fun. Woo, woo. Okay, that would be like a real fun spiral. But if I put it down on the table and I let it go and it goes out to here, I want you to make a prediction for me. Where is that ball going to go? So some options would be that it would go, so again, I'm setting it on the table. I'm just holding it up so you guys can see it. One option would be that it would go like this. One option would be that it would go like this. One option would be to go like this. One option would be that it would fly in the air. I don't know. There are lots of different options. I want you to make a prediction. Which direction do you think it's going to go in? Okay? Draw me a picture. Draw me a picture. You want it? Yes. Sweet.
Are you done?
Yeah, I'm done now.
You're tiny king.
She's so funny. I love that. What's that?
She had her shoes on.
I know, because I think she wasn't running fast enough with her shoes on. That's so funny. She's so cool. All right. So, you got a prediction written down? Maybe I'll go steal it from at the very end so we can find out. We'll see. I want you to look up here before you get your Chromebooks out. We have, let's see, 35. So I'm going to give you 20 minutes. That'll get us to 9. Oh, that's going to be tight, you guys. I'm going to give you 15 minutes to get started. I want you to look up here, though, so please don't talk. You opened this up yesterday, but I want to make sure that you understand. So it's going to be on Canvas, okay? You're going to click on it. You're going to open it up, or you've already opened it, so it's in your Google Drive already. I want you to write down the prediction. So use the spiral. Write down your prediction. Where was the spiral going to go? Okay? And then I want you to look at this objective. The question says, why do the planets stay in motion around the sun? So for each of the things that you have here, so step 2, step 3, they just keep going. I just snip this out so it's just a little bit. After you answer the questions in the middle part, I want you to look at the objective and see if you can put a little bit more information there as to why the planets stay in motion around the sun. Okay? Does that make sense? I'm going to give you 15 minutes to work fast. Work hard. You've got this. All right? Go, go, go.